Namaskar, this is the physicist, and today we are going to discuss briefly about finding the mode of group data. Basically, this is a topic from statistics, and the reason why I'm making this very short video about this particular topic is that while I was answering and discussing statistics to the 10th standard CBSE students, I came across this topic where there is a formula actually to find the mode of the group data, but most of the students didn't know the intuitive understanding. They didn't have the intuitive understanding of the formula. The formula is something like this. If there is a class, for example, there is, let's say, we plot frequency versus class, okay? And there happens to be like this a structure, or let's just make it a little different here. Okay, in this particular data, this particular bar happens to be the modal class. Okay, there are class, each has a class size of hn, h. Every class is of the same identical size. And when we make this frequency distribution group data, what happens is, let's say this is the modal class, alright, and this is the class which precedes the modal class, and this is the class which actually succeeds the modal class. Since it is the modal class, let's say this has a frequency f0, this has a frequency f1, and this has a frequency f2. Since this is the modal class, as we know, for every mode is the one that has the maximum frequency. Okay, so for modal class, again the frequency has to be the maximum. That means f1 is going to be the greatest. That means f1 is greater than f0 and f1 is also greater than f2. So that being the case, how do you find the mode? So we know that this is the modal class, but where do you find the mode? So somewhere inside this interval, there happens to be a point. If the lower limit is L for this modal class and this particular distance is X, so that particular value of mode which is given as Z is L plus X. But there is a formula given in the NCERT 10th standard maths book, and I guess the chapter is 14, and they have actually given this formula as L plus f1 minus f0 upon 2f1 minus f0 minus minus f2 times h. H is the class. So what is f1? It's the frequency of the modal class. f0 is the frequency of the class preceding the modal class, and f2 is the frequency of the class which succeeds the modal class. Okay, so this is the formula. L is the lower limit of the modal class and h is the class size. But most of the book doesn't have, the NCERT book does not have any kind of explanation for this formula. It doesn't give any derivation to this formula, and most of the students don't know how this formula is derived and why it is so. And even on YouTube, I did not find much of any explanation videos that I could actually point them to. That's why I decided to make this particular video. So what I can assure you from this video, that if you go on watching this video till the end, you will never have to remember this formula, which actually looks a little bit difficult to memorize, and only through practice you will be able to master it so that you can recall it in the examination, this being a very important topic in the math paper. But I can assure you that you do not have to remember this formula at all. Why so? Because I am going to give you an intuitive understanding, so that whenever you face any such questions on finding modes of group data, you will be able to recall the formula from your intuition itself. Okay, you don't have to carry this burden, or even if you lose practice over this, you will still be able to remember this formula forever. Because once the intuition grasps the concept, you will be able to totally have this in your heart. Okay, so that's what we're gonna do. Stick to the end and watch the entire video. It's going to be as short as possible. So let's just forget this thing entirely, the formula and everything. Let's redraw the graph. I assume that you already know what is mode, what are the characteristics of group data, and what is class size and all. So if we do that, I am going to draw this diagram or the frequency distribution of the class group data like this. The frequency goes like this, and here goes the classes, okay, the bar graph. Now, or rather you could say the histogram. Here, and this one is the module class. Just assume that class size is identical, and this one is the class preceding the module class. Since this is the module class, it definitely has the frequency which is highest of all the classes. So that also means that it has a frequency higher than the class preceding it. It also has a frequency higher than the class succeeding it. Okay. So in this case, you can see that when we proceed from the left to right, as it has to be, this particular section, there is a rise in frequency and there is a fall in frequency. Okay, so let us denote rise as capital R and fall as capital F. Okay, small f stands for frequency. So now to find the exact mode or the approximated mode, the mode has to be somewhere inside this interval, a particular point. If the lower limit is L and the upper limit is U, then it has to be at a certain distance from L. Let's say this is X. So, and that point is going to be assumed as our mode. Okay, but it has to be in such a way that it does justice to rise as well as fall. That means we cannot just find some point inside this interval arbitrarily. There has to be a logic, a point. So the point is that the rise and fall, they are both taken as numbers, okay, pure numbers. They are not given any kind of signs. So basically, the rise and the fall, they could be same, they could be different. Even the rise could be 0, the fall could be 0. If rise is 0, that means these two both belong to the same module class, okay. And if the fall is 0, then these two belong to the same module class. But in general speaking, if R is not equals to F, or R is not equals to 0 and F is not equals to 0, okay, and let's also say that R is not equals to F, okay, R is not equal to F, R is not equal to 0, F is not equal to 0. In that case, that means we have some rise which is not the same as the fall, but there is a quantity, we can say, what is the ratio of the rise over the total of rise and fall? That could be a quantity. Again, we can also say that what is the ratio of the fall over the total of rise and fall. So these are two things. So basically, when we take go from left to right, the x has to be such that let's say this is x and this is y. Okay, so the x versus y. So x upon y has to do the justice of rise over fall. That means x upon y has to be the same as rise over fall. Okay, so that's the point, that's the central point which is behind this entire formula, because that's the logic that we are taking, that the x has to be at such a point where x upon y, what is y? Y is basically, you can say y is the class size minus x. So x upon y has to be the same as rise over fall. So that's the entire point. That means we have to take somewhat around rise over total change, rise over rise plus fall, and the other quantity is fall upon rise over fall. So if we somehow find this quantity, because if we take the ratio x upon y, so if we take r upon r plus f divided by f upon r plus f, then it is going to give us r by f. So we don't have to consider this anymore. We have taken the central idea that it has to be proportionate, okay. The x has to be chosen at a point that has to give it a proportionate distance from L. So r by r plus f. So that means now we understand what principle we are going to follow to find the value of x. Okay. Now all that remains is just geometrical deduction from this particular diagram. So for that I am going to draw certain triangles here. So let's just say that we connect this particular point with this one and this particular point with this one. Okay, these are all straight lines. Now this particular point we have to connect by a straight line. Okay, that's the perpendicular. Okay, now let's name those points. A, this is B, and this is C. This point is D, and this point is E, and this point is F. Okay, so A, B, C, D, E, F. We have named all the points. What we need to find is X, because if we know how X is, if we know what X is, then we can find the mode as Z equals to L plus X. That's the entire point. So we have to find X. So the reason why we took this perpendicular here is because that is the same as X. Okay. So EF, that means L plus EX, X is EF, L plus EF. So that's the point. Okay. Now we have to find EF. How do we find EF in the ratio? We know R and F because the data has already been given to us. So R and F we know. Okay. So what is R? R is, this R is F1 minus F0, and fall is F1 minus F2. Right? And R plus F, what is R plus F? R plus F is F1 minus F0 plus F1 minus F2, that gives us 2F1 minus F0 minus F2. So that's the total, R plus F. Okay. Now see that these two triangles, the triangle BEF, this triangle BEF is similar to the triangle BCD. You probably would ask why. Why? Because first of all, in these two triangles there are two right angles. Okay. Now, since these two lines are parallel, so this angle is the same as this angle. Okay. Since two of the three angles are same, that means the third angle is going to be the same. So by satisfying the condition of equal angles, these two triangles BEF is similar to BCD. So in that condition, let's just say the triangle BEF is basically similar, not congruent, is similar to triangle BCD. Okay. In that case, the height, let's say EF is the height. So EF, the ratio of the heights, EF upon BC is going to be, EF upon BC is going to be BE, the hypotenuse, BE upon BD. Okay. Now, what is BC? That is the class interval, which is BC is basically U minus L. Okay. So BC is U minus L, and that is U minus L is the class size, which is H that we have taken. So EF is basically X. So X upon H is going to be BE upon BD. Right. So we have come across to this point. Okay. We have come to this point so far. BE upon BD. That is something we don't know, but we need to know. How do we do that? We set another pair of triangles and see if they are similar, and then we go on and derive from their deduction. So let's just erase, because there is not much of a space. I'll just transport this particular formula here. That means so far we know that X upon H is BE upon BD. Alright. We don't need anything else. So now these two triangles, look at this. ABE, these two triangles, ABE, and the other triangle is CED. These are two triangles again. And why we are taking these two triangles? Because we already know each one from the three sides. Okay, we already know what is the value of AB. That is, AB is the rise, CD is the fall. Okay, we already know that. So we take these two triangles, and here also the same thing. These are the opposite angles. They are same. Since they are two parallel lines, this is the same as this one, and this angle is the same as this one. Okay, that means three angles are identical. That means these two triangles are similar. So since the triangle ABE is similar to the triangle CED, CDE, let's just say CDE, these two triangles, that means AB, since this is the condition, or this is the fact, we can derive that AB upon corresponding side CD is the same as BE upon ED, right? That implies AB. What is AB? AB is basically the rise, which is rise upon fall. CD is fall, is going to be BE upon ED. But we know we need BE upon BD. We have BE upon ED. We have BE upon ED. But we know we need BE upon BD. So what is BE upon BD? BD is BE plus ED. Right? So somehow if we can add BE and ED together, we'll find BD. Right? We already have BE. We don't want to disturb BE. We only want to add BE to ED. So how do we do that? Let's just invert it. F by R, we just invert both sides, make it ED upon BE. And then what we do is, let's just save some space, is same as ED upon BE. We just add 1 to both the sides. What happens? Then it becomes R plus F in the numerator. In the denominator it remains R, and it becomes ED plus BE upon BE. ED plus BE, what is ED plus BE? ED plus BE or BE plus ED is BD. So we are going to get BD here, and this one remains the same. All we have to do to find BE upon BD is to invert this same thing again. So R upon R plus F is going to be BE upon BD. Okay, and that is, as we know, BE upon BD is X by H. So from there, what we can, let's just erase this, clear this space. We are at the end. From here we can say that X is H times the numerator. H goes to the denominator. H goes to the numerator and gets multiplied. So X is H times R upon R plus F. So what is R? H times R. R we have defined R as F1 minus F0. So it is F1 minus F0 upon, or rather we'll do the bracketing later. F1 minus F0 R plus F. What is R plus F? R plus F is, again I'll do it once more. R is F1 minus F0 plus F. F is F1 minus F2. So R plus F is 2F1 minus F0 minus F2. Okay. So don't get confused. The point is, don't get confused with all these terms. Just see things as rise and fall. Everything will come back to you. Okay. So F1 minus F0, R plus F is 2F1 minus F0 minus F2. So we have found value of X. So what is the modal point, not the modal class. What is the modal point? Point is lower limit L plus x, which is modal point Z is L plus x, which is L plus f1 minus f0 upon 2f1 minus f0 minus f2, and that is multiplied by h. So we got this point. Now, so far we have understood this. This thing can also be done in the reverse sense, like you can also y from left. Just to verify, why just taking all the things from the left to right? Why can't we just do it from the right to left? Okay, let's do that. We should be able to get the same formula. We have already obtained the value of x, which is let me just wipe this thing out. Let's say we do it from the upper limit. Okay, so upper limit u is L plus h, we know that, and this particular value of x we have obtained this as rise upon rise plus fall times h. Okay, now y has to be fall upon rise plus fall times h. Okay, because if you sum x and y, they are going to give you h only. Now what you can do, you can find the point, the modal point from the right hand side, which is z is going to be upper limit minus y, that is upper limit. What is upper limit? L plus h minus f upon r plus f times h. In that case, it is going to be L plus h minus of the entire thing. This is h minus RH by r plus f. Basically, I converted f to h minus RH by r plus f. So in that case, again it becomes L plus h minus h plus RH by r plus f. H cancels out and this leaves us with L plus RH by r plus f, which is again the same formula. L plus, what is rise? f1 minus f0 times h upon r plus rise plus fall. What is that? 2f1 minus f0 minus f2. So we also get the same formula. You see, the formula might look a little bit difficult to understand intuitively in the beginning, but if you understand how it is derived, the logic, it is going to be very intuitive. There are two things actually to understand. The first thing is that the x, or the point, modal point, is taken in such a way that the distance it has from the lower limit and the distance it has from the upper limit, both these two distances are in the exact ratio of the rise in the left to the fall in the right. So, and then the deduction follows, and that gives you with this formula. I think if you understand that, if you don't understand it at one go, revise the video and watch it again, and you will understand. If you have any questions, you can just ask me in the comment section. That's it. That will be the conclusion of this video. Thank you for watching.